Welcome to Practical Introduction to Logic. In this tutorial, we'll introduce... Welcome back. In this tutorial, I'll introduce categorical propositions. We'll start with the elements that categorical propositions are built out of. We'll talk a little bit about types, and I will introduce the square of opposition, and then we'll conclude with an overview of diagramming. So let's start with elements. Okay, let's look at an example from the previous tutorial. All cows are mammals. All right, so now we can represent the category cow with a capital C just for convenience, and we can represent the category mammal with a capital M also for convenience. If you think about the relationship between C and M, you'll realize that one way to sort of visualize this is that M is a large category and it completely includes the category C. So in other words, this informal diagram represents the relationship between the term C, or cows, and the term M, mammals. All of the categorical propositions operate more or less like this. There is a subject term that's in the subject place of the sentence grammatically, but it's also the category that receives the claim, and the claim is the predicate term. It's called predicate. Okay, so those are two ingredients, the subject and the predicate. The other indicators here, like all and are, tell us something about the way the relationship is formed between the subject term and the predicate term. In this case, we're saying all cows, which means every member of the category cows. In other words, if anything is in the category cows, then the rest of this sentence, the predicate, applies to it. And so what applies to it? It's a mammal, right? And that's exactly what we captured in this informal diagram. So we could call it informally the amount or the number. The real issue is how much of the category is being asserted as having the predicate. So let's compare that, for instance, to the proposition some cows, let's use C for cows, are jerseys. So now if you think about this relationship, we've got two terms, C and J, and I drew it this way to overlap because there may be some cows that are not jerseys, and there may be some jerseys that are not cows. We don't know about those two because the only thing that's being asserted in this proposition is that there are some cows that are jerseys. In other words, this region has something in it, and that region is the overlap, which means that there are some things in the circle representing the category cow that also are in the circle representing the category J. But the important thing here is, do you see the difference between claiming that every member of a set, the cows, is a mammal, compared to every member of the set, the cows, some member of the set is a jersey. So this tells us that it's not every member that we're talking about, but only some. So that is a characteristic that we call quantity. The quantity of a categorical proposition tells us whether we're talking about every member of the subject term or only some members of the subject term. When we're talking about every member, then we call that a universal proposition. And when we're talking about some members, not the whole set, but some, then we call that a particular proposition. So what that tells you is that these categorical propositions could be either universal or particular in terms of their quantity. So now let's look at another characteristic Suppose we go back to this example of no cow is a reptile. Okay, so here we're using capital letters to stand for the category cow and the category reptile. Now, in this case, if we look at this intuitively, the way we could visualize it is that there is a circle that represents the category cow, and there's another circle that represents the category reptile, and notice they don't overlap at all. They have no members in common, and that's what we mean by asserting no. The thing that's tricky about this proposition, though, is not only does it say that some category is being excluded from some other category, it also implies, because of the no C, like no cow, it also implies that it's universal as well. And in fact, if you think about it, what we are claiming here is something about every member of the set of cows, namely that it's outside or not included in or excluded from the category reptiles. So what does it look like when we're doing some excluding like this, but we're only talking about some members? In other words, a particular. It looks like this. Some cow is not in the category Jersey. Right? So we could represent this as overlapping circles. So this is the cow circle here and the Jersey circle here. And again, now this because of this overlap, we have three regions. We have the region of C's that are outside of J, in other words, excluded from J. That's what this proposition is about. Some members of C are not members of J, right? But we have two other regions. As we saw in the previous example, we have the region in this diagram of C's that are J's, so that's why the circles overlap. And then we have a region here that indicates the J's that are outside of C. Now, notice this proposition is just claiming something about the C's that are not J's. It doesn't give us any information about whether there are C's that are J's, and it doesn't give us any information about whether there are J's that are not C's. So that's why I use this diagram of overlapping circles, because we have to not take a position on any information that isn't explicitly given to us in the categorical proposition. Okay, so this characteristic of excluding things, usually indicated by a negative of some kind in ordinary English, right? Like no C is an R or some C is not a J. This characteristic is called the quality, right? And the characteristic that we're looking at here, the exclusion characteristic, we call a negation. So you have to think about negation is not exactly like negation in grammar, where we're saying, like I'm not hungry. It's in categorical propositions, negations are about excluding members of a category from other members. If we go back to our previous example, where we're talking about members of a category being, sorry about that, members of a category being, okay, I think we've got it now, being included, the inclusion as opposed to exclusion is called the affirmative. And so with the affirmative, some members of a category are being included in other members. Okay, so let's summarize what we have identified so far. So a categorical proposition has these ingredients. It has a subject term, and that subject term receives the claim, as it were. So that's what cows was in this previous example. So the subject term receives the claim. We have a predicate term. The predicate term is the claim that's being made about the subject. We have quantity And remember, quantity comes in two kinds. That's either going to be universal, if we mean every member of a set, or particular, if we mean only some. And then we also have the quality. Quality is going to be either inclusion or exclusion. When it's inclusion, we call it affirmative. And when it's exclusion, we call it negation. So affirmatives and negatives. And then we have only one other ingredient to talk about, and that is categorical propositions in their standard form, like the form that we want to see them in for doing logic, will be based around what we call the copulative verb. This is a form of the verb to be. Now, what do I mean by the form of the verb to be? There are a lot of ways to state a categorical proposition that may not make it evident that we're really talking about two categories. So for instance, I might say all snakes lay eggs. So if you think about this, it's not exactly clear, although snake does seem to be the subject term, right? So we could use S for that. But what's the predicate term? Well, if you think about it, the predicate term could be stated as egg layer. Let's use E to stand for egg layer, and then in that case we can say all members of S are, is, whatever, this is a form of the verb to be, is a member of the category egg layer. So this is a little bit closer to ordinary English maybe, but this is the standard form for a categorical proposition, which makes all the 5 ingredients explicit. So look what we have. We have a subject term, we have a predicate term, we have a quantity, that's universal, every member of the set S. We have a quality, every member of the set S is what? Is included in something, so inclusion is the quality. And we make the relationship between the subject and predicate term explicit by using a form of the verb to be.